Lecture 7.3, Day 3, the Shell Method. This is a Japanese spider crab. The photo was taken at the Georgia Aquarium in Atlanta, Georgia. This is a baby that was about the size of a dinner plate. When full grown, these grow to be over 12 feet wide, and they live 100 years. They live off the coast of Japan. Preface. Suppose we want to know how much steel is used in the side of a can of crab meat. If we unwrap the side of the can, the resulting shape is a rectangle. The width of the rectangle is the circumference of the can, 2 pi r. The height of the rectangle is the height of the can, h. The thickness of the metal is a small change in the radius, dr. The volume of the side of the can is 2 pi rh dr. New problem. Find the volume of the region bounded by y equals x squared plus 1, x equals 2, and y equals 0, revolved about the y-axis. We can use the washer method if we split it into two parts. The equation of the curve was y equals x squared plus 1. We need to solve for x, so we get y minus 1 equals x squared, or x equals radical y minus 1. Our integral becomes pi times the integral from 1 to 5 of 2 squared minus radical y minus 1 squared dy plus pi times 2 squared times 1. So we have the outer radius squared minus the inner radius squared the thickness of the slice is dy, and we have to add the volume of the lower section, which is a cylinder. Our integral becomes pi times the integral from 1 to 5 of 4 minus y minus 1 dy plus 4 pi, or pi times the integral from 1 to 5 of 5 minus y dy plus 4 pi. We find the antiderivative, plug in the limits of integration, and simplify. And we get our answer, which is 12 pi. Here's another way we could approach this problem. If we take a vertical slice and revolve it about the y-axis, we get a cylinder. If we add all of the cylinders together, we can reconstruct the original object. There's a cross-section. The volume of a thin, hollow cylinder is given by the lateral surface area of the cylinder times the thickness which is circumference times height times thickness, or 2 pi r times h times the thickness, where r is the x value of the function and h is the y value of the function. The thickness is dx. Giving us 2 pi x times x squared plus 1 dx, where x is r, 2 pi x is the circumference, x squared plus 1 is h, and dx is the thickness. If we add all the cylinders from the smallest to the largest, we have the integral from 0 to 2 of 2 pi x times x squared plus 1 dx. We can factor out the 2 pi because it is a constant and clear the parentheses. Then we take the antiderivative, evaluate with our limits of integration, and we get our answer, 12 pi, which is the same as we got last time. This is called the shell method because we use cylindrical shells, shells being hollow with a thin outside layer or shell. Find the volume generated when this shape is revolved about the y-axis. There's our model. We can't solve for x, so we can't use a horizontal slice directly. If we take a vertical slice and revolve it about the y-axis, we get a cylinder. Using the shell method, the lateral surface area of the cylinder is equal to the circumference times the height. So we have 2 pi r times h. The volume of a thin cylinder then is 2 pi r times h times dx. In this case, we integrate from 2 to 8, and those are x values because our variable of integration is x. We have the integral from 2 to 8 of 2 pi x times our function. So there's r. 2 pi r is the circumference, and our function was h. Dx, of course, is the thickness of the shell. And we get 160 pi. Or about 502.655 cubic centimeters. Note, when entering this into the calculator, be sure to enter the multiplication symbol before the parentheses. Otherwise, right here, the calculator does not recognize implied multiplication and it thinks that x is a function. When the strip is parallel to the axis of rotation, use the shell method. When the strip is perpendicular to the axis of rotation, use the washer method.